What is a binomial experiment? A binomial experiment has a fixed number of trials where each trial is independent of the others. There are only two possible outcomes for each trial, and they'll be classified as either a success or a failure. The probability of success has to be the same for each trial, and we'll use the random variable x to count up the number of successes. So for this example down here, number 1, let's decide whether it's a binomial experiment. 24% of people in a certain city who are eligible to donate blood actually do. You randomly select 4 eligible blood donors and ask them if they donate blood. Now, it didn't explicitly say that we were doing it with or without replacement. I think the way it's written implies without replacement, so you're selecting 4 different blood donors. If you do it without replacement, then the probability of 24% may vary slightly. The key here, though, is slightly. Because it's a population of a city, we're talking about a large number of people. So we can assume that the percent chance of somebody answering yes here to the question would be roughly 24%, no matter who is selected. So I would say the trials are close enough to independent that it could be treated as such. Also, we see that it's a yes or no type of question, and that's what you want to look for. Think about what kind of responses a person might give to the question. If it's a yes or a no that they might answer, then that's a good indicator that we may be dealing with a binomial experiment here. So yes or no type of question, I'll say approximately independent trials. And yeah, so what's a success? Finding a person who is a donor Yeah. Okay, now let's figure out what the values of n, p, q, and x could be. So n is the number of people asked. Which is 4. N is 4. P is the probability of success. 24%. Q is the probability of somebody saying no. The probability of failure is 0.76. Now when it comes to X, X is the number of successes that we encounter out of 4 people asked. So it's possible that nobody is a donor of those 4. Or we might find 1 donor out of 4, or 2, or 3, or perhaps even all of them will be donors. The point is that X could take on many different possible values, 0 through 4. Let's check out this next one here. It says a state lottery randomly chooses 5 balls numbered 1 through 40 without replacement. You write down 5 numbers on your ticket. The random variable represents the number of matches on your ticket to the numbers drawn in the lottery. All right, so a success would be matching. a number on your ticket to a number that's drawn. So let's see. If they were to draw their first number, and you've got 5 numbers written down, then you've got a 5 in 40 chance of matching on that first trial, you know? Okay. But then what's going to be your chance on the second trial? Well, it kind of depends. If you didn't match on your first pick, on their first ball drawn, then you might have a 5 in 39 chance on the second trial, see? Or maybe 4 in 39 if you did match the first time. So as you can see, the probability of success here is changing. And here it's a pretty drastic change. It's not like you have a whole city population to pick from, as we did in the first one. The first one, the population is so big that any changes in the probability would be insignificant. But in this case, with the lottery balls, because there's a relatively small number of them, you could argue that the trials are not really independent enough. So for that reason, I'm going to say not binomial. All right, here's another one. A coin is flipped 4 times. In 3 of the 4 trials, the coin lands on heads. Find the values of all the following variables and state the meaning of them. All right, so this is a binomial experiment. Coin tosses are independent, and they have the same chance of occurrence. And that's what we want to write down for P, is the probability of success. So it's a 0.5 chance. And the way the question is written here, I'm going to call a success heads. Q will be 0.5, the probability of failure. Okay, N is the number of trials that were attempted. Number of tosses total. Here they said 3 of the 4 times that you flipped the coin, it landed on heads. So that's actually going to be our X. Number of successes in 4 trials. And we're also going to want to calculate N minus X. We'll see why when we use the formula for binomial experiments here shortly. N minus X would be 4 minus 3, which is 1, and that would actually be the number of failures in 4 trials.